Hi, welcome to your video on writing function rules. This is where we will focus on being able to write equations that represent functions more specifically, so that we can get very good at writing them. Let's get started. First, we have some examples of linear functions and writing rules for those. So here we have a topic about insects. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps of the cricket that it makes in 1 minute. So what is the function rule that represents this situation? So the temperature is 40 degrees more than 1/4 the number of chirps. Oops. And that's in 1 minute. So you're going to take that information. That's the important information of this whole thing. The other stuff is just words. So T is going to be temperature. And so that's T. And then N is going to be the number of chirps. So that'll be N. And using this, we can write our equation, and we will have T equals 40 plus, because that's what more than means, and it's 40 more than 1/4 the number of chirps that we have. So the function rule is T equals 40 plus 1/4 N. Another one is concert revenue. This is a true thing. Many of you have probably been to a concert. There's general seating and then reserved seating. And obviously it's more expensive for reserved seating because it's closer to the stage and there's less of them. So what we're going to do is write a function rule off of this. Oops. What's going on? Sorry about that. Okay. So here's what we're going to take this information. So the total revenue, or how much is made, is the general seating plus the reserve seating together. But general seating has the price per ticket times the number sold. So that's a little bit different because it's not just a flat rate, okay? Everything has its own. Some seating you might fill, some you won't. Reserve seating, you're going to fill all of it, so it's just a total there. So we are going to have R be the revenue. We're going to have N be the, N be the number of general seating. And then we have our added on reserve seating. So here we go. Our equation then, the revenue, how much money we make, will be equal to the $10 per ticket. Okay. And that's coming here, the $10. Okay. And then it's how many tickets are sold. So R equals 10N plus we have our reserve seating. This reserve seating is $25 each. Okay, so we are going to have $25 times the 10 rows, and there's 12 seats per row. In other words, there's 120 seats. You could have also just taken 25 times 120, but this works too. So then our final way to write this would be the revenue will be the number of general seating plus $3,000. Now the final question after all of this is what is the maximum possible total amount of revenue? In other words, how much can they make if it's a sold out concert? So R equals 10 times how many possible open seats there are. There is 30 times 16, which is 480. So total of possible 480 seats to fill, plus that $3,000. And when I solve this, I am left with $7,800. So the total amount of money that they can make would be $7,800. All right, a nonlinear example for you when we're talking about geometry. Sometimes this stuff will be not linear because most things in geometry aren't even linear. They're shapes. So here, write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of a rectangle when its width is 9 feet? Excuse me. So here's the important information. The length is 5 feet more than the width. Okay, and then we also know that the area is length times width. So important figures here to talk about. Here we have this first normal one. That's what you know, the area is length times width, and it looks like this. So when we have a length that is 5 feet more, what we're going to do is write that in terms of the width so that we only have one variable. We can substitute in W plus 5 for L because it's 5 more than the width, so we're just adding on 5 there. So our rectangle will look like this. We'll have W on the short side and then W plus 5 on the longer side. And then we can use that to write a function rule, and we know area is length times width, so we're going to use that same one, except for because we're substituting in the W plus 5 for L, that's what we're going to write. It's going to be W plus 5, and then we're going to take that and multiply it times W. In other words, another way to write that, here's your distributive property coming into play because you're multiplying. The other way to write that would be A equals W squared plus 5W. And that formula will be able to work for everything. Here we go. To answer the question, width is 9 feet. So I'm going to drag and drop 9 in. So 9 squared plus 5 times 9. 9 squared is 81 plus 45. The area then is going to be 126 feet. Okay, it is your turn to practice these writing of rules and solve them. So don't forget to do both of those things. That's why I have them 2 colors in here. So number 1, the area of a triangle whose height is 4 inches more than twice the length of its base. So you're going to write a function rule, and then you're going to solve it for when the area is, or the base is 16 inches. Second question, a kennel charges $15 per day. Then upon arrival, they must have a flea bath, which is $12. So write a function rule, and then use that rule to answer how much does a 10-day stay cost. Go ahead and do this. Show all of your work on your notes page. Don't leave anything out. Make sure it's getting all on there, and then you can check back in with me when you're done for the answers. Okay, question number 1. I don't have too much space, but here we go. Question number 1, your formula is A equals B squared plus 2B. And then your answer then would be 288 inches squared. Now, I'm not going to accept just an answer, so make sure you have all of your work to prove that you know what you are doing. And then the last question about a kennel. Here we go. It is the cost equals 12 plus 15N, and then a 10-day stay would be $162. Again, make sure you're showing your work on those questions. Alright, that is all I got for you for this video. If you have any questions, make sure you're either emailing me, asking someone else in class, or bringing those questions and discussing them in class. Thanks for watching.